So for this session, we have Dirk Hundel from Open Source Technology at Intel, Open Source Technology Center at Intel, and he's going to talk to us about scratching your own itch subsurface diving log. So please welcome Dirk.
Thank you. Good afternoon. As they always say, they keep the best for last. So I don't know why I'm in this time slot, but hey, I'll try. So let's start with a couple of very important questions. Who in this room is a scuba diver? Okay, who's not a scuba diver? Why are you here? So when I submitted this talk, the idea for the talk was very much to find an excuse to talk about subsurface. So I came up with a few ideas why this would be interesting for an LCA audience, especially since usually you run into a lot of scuba divers here. But then I decided to actually use subsurface just an example on what happens if you try to write an application today with the environment that we have today. What are the things that are easy, what are the things that are hard, and oh, by the way, what are the things that are interesting about it? And so that's going to be the majority of the talk. So I work for Intel in the Open Source Technology Center. This presentation has very little to do with Intel. I think I can make it a stretch and say it's about open source, and that's what I do. I'm the chief Linux and open source technologist for Intel. But that's really a stretch. It does have a lot to do with open source. I've been doing open source for about 25 years, long before it actually was called open source. It was free software back then. And when programmers were real men and women. But I was involved in Linux since '91. I was lucky enough to be one of the first people who saw Linus's fateful post on Compose Minix. And I actually had the right kind of computer, a 386 SX 16 megahertz with 4 megabytes of RAM. It was awesome. I don't do slides, ever. I am fairly famous for giving presentations without slides. And I actually got a lot of grief from some of my friends who are here, about the fact that I have a presentation this time. But a chance to actually have my own underwater photography displayed on a screen, there is no way I was going to skip this. So everything you see here are actually pictures that I've taken. These are Big Eye Jacks in Mexico, in Baja California. So these were taken in a marine reserve, which is the only reason why you can see swarms like this, so fishing is prohibited. And it's really funny, if you swim out of the marine reserve, it's a border. The fish know. There's no fish there and all the fish here. It's awesome. Anyway, so chronologically this picture is wrong, because this picture of Linus was taken about a month ago in Hoodsport in Washington State. And you see him wearing, a twin 95, and he is not wearing yet the 2 stages, because the next day we did our trimix class. So he's actually not really weighted down yet. But of course, he's the one who actually started it, and he's sitting there. So if anything is wrong, blame him. And as it happened, Linus was bored. He wasn't bored for a good reason. He was bored because kernel.org had a little mishap. And so the flow of patches slowed down for Linux. And he had time to deal with one of the things that annoyed him, which was the lack of a decent divelog program that would run on Linux. And I'll talk a little bit later what that means, decent. And so he started writing an app. And as we all know, anybody who follows him on Google Plus knows that Linus is a very famous connoisseur of high-end UIs and anything graphic and design. He, of course, decided to start on a UI application. And the first versions were absolutely gorgeous. It was awesome. But the interesting thing is, so if you start with a new project today, you are not starting from scratch. Well, you kind of are, but in the larger context, it's not like 20 some odd years ago where you would use hopefully something advanced like XT or XR to draw something on the screen, or if you had the money, you'd have CDE, and you'd even have routines that do, you know, full shaded rectangles and not just outlines. Today we have a lot more available, and that really makes a huge difference when you're starting to write software today. And especially in this context where you want to support a wide array of hardware that is almost all proprietary, almost all ridiculously badly implemented. Looking at the transfer protocols from a hardware perspective, from a software perspective, the dive computers use makes you cry. It is awesome. So it's mostly two-line serial interfaces connected to the cheapest USB dongle money can buy, and then they sell you that cable for $100. And what was it? The Gecko had 3,200 baud, something like that. It was insane. So you wait like 4 minutes to transfer the equivalent of 30 kilobytes. It's just awesome. The very newest computers are getting a little better or terribly worse, and there are lots of anecdotes to tell about that. But fundamentally, talking to dive computers was something that no one would want to re-implement. And thankfully, there is libdive computer, an open source library that is used by a couple of proprietary dialog programs already. And it talks to dive computers, but of course, it's a C library. So if you are trying to write a Java program or an HTML5 applet or something, it's a real pain in the ass to talk to it. And the more you look into what you're trying to do, the more you realize there is a library or a tool out there for almost anything. Whether it's dealing with XML files, reading and writing them, parsing them, understanding them, talking to a web service to download data from the web, showing maps, which is something that we just recently added. And of course, you have all these, you know, the things we take for granted, the tool chain, the operating system, the editors, and all that around it. So Linux was the target platform in the beginning. Linus, obviously, targeting Linux. When I joined the project a couple of weeks later, after he had the first working version that he sent to me, I pretty quickly said, hey, it's GTK, the library supported. We should be able to do this on Windows and Mac, and so we have versions on Windows and Mac that work reasonably well, where reasonably well means however well GTK has been ported. For most everything that goes wrong on our Windows and Mac ports, it's reliably GTK that screws us up. Which, oh, by the way, could have been the title of that talk. GTK will screw you up. Because, as it turns out, neither Linus nor I are UI programmers by any stretch of the imagination. And the way our GTK code was written was with the help of Dr. Google. I want to do this. Let's Google it. Oh, there's a code snippet. Let's see what it does. Ooh, it doesn't work. Let's look for another snippet. And it's very funny, at various points throughout the evolution of the project, we had actual GTK people look at the code. And once they stopped throwing up, they usually were able to give us a little help, and then they normally run as quickly as they can because they're like, oh my God. GTK has its challenges. Worst of all is the API, the ABI, the documentation, and the UI design. Wait, no. Let me rephrase that. GTK has its challenges. The documentation works great if you know exactly which function you're looking for and how it is supposed to be used in the context that you want to use it. And especially if you only want to use it the way that the authors of GTK have intended. So there are very simple things. We have a little tree view where you have trips, dive trips, and you can fold away the individual dives of the dive trip. Seems like a very logical thing to do. And of course, we have multi-selection, so you can select multiple dives, and you can do statistics over them, all kinds of stuff. Now, if you collapse one of those trips, GTK in its wisdom decides that no longer can dives in, or elements in this group be selected. So you collapse, uncollapse, boom, they're no longer selected. Well, it's easy. You can try and track the selection yourself, except that I don't know how many times now we've stumbled across something else where GTK makes a magic assumption inside that it's only them who are tracking the selection. And if you meddle with this, you get GTK seriously confused. It's other things. It's ways in which sort order gets lost if you change the model that you're displaying. Simple things that you think would be straightforward, that either cannot be done, or when you find someone who explains to you how they can be done, you go like, really? Awesome. But let's not just complain about GTK. We made, I guess, the mistake to work on the development version of libdivecomputer. And libdivecomputer is an actively managed project with one main developer. By sending so far, I believe, 9 patches, I'm now the #2 developer on libdivecomputer, which tells you a lot about the project. And Jeff has written awesome code. libdivecomputer is phenomenal. The way the API is designed is, let's go for surprising. But the way within this development version he deals with versioning or lack thereof is the thing that truly can drive you up the wall, because he will, push out a new set of changes that, add a few arguments to function calls, change the meaning of some things, add constants, remove constants, and there will be absolutely no way to detect this. There's no change in any version number, in any macros. He loves enums over pound defined, so you can't do if-def. It's all enums. And so basically the only way you know that, oh, this has changed in the latest version is your compile fails. Which is nice, I guess, if you're doing a proprietary software product and you pick the one you want, you change your sources to compile, you create the binary, and off you go. But if you have a community of developers, if you want to get this into Fedora, into Debian, then there needs to be a way to, say, guarantee this stuff actually builds. And that has turned out to take a lot of convincing. Now, since we have become a consumer of libdivecomputer, we actually have gotten Jeff to do releases. Awesome. So now every few months there is a v0.1, v0.2, and in a couple of weeks there will be a v0.3. And at least as long as we take our releases and make sure that they rely only on the features in one of his releases, we kind of synchronize this all works. But it does seem really, really painful, let me tell you. And I can continue these stories. The maps widget. There's a really cool maps widget, except that the world is flat. So if you go west from Hawaii, there's Nirvana. If you go east from Fiji, there's also Nirvana. They don't meet. And so if you try to do visualization of dives and you have someone like Linus who has GPS locations of his dives in Fiji and Hawaii, never mind. There are other very strange oddities when we just figured out that when they tried to implement scrolling of the widget, they didn't quite think this through, and you got this nice psychedelic effect where you, by scrolling out, woo, you went off the screen. It was really awesome. But of course, when you do a project like this, it's not only the code that you need, the libraries that you need, the tools that you need. You also want to build a project around this. And that was one of the areas that I found absolutely fascinating, because the open source community over the last 15, 20 years has literally built everything you could possibly need, and then 17 versions of it. And mailing lists, source control management. Strangely, there was a little preference for Git in our team. I don't know why. How to build a website. I'm a kind of a blogger. I used to be a blogger, I guess. So I decided to just use WordPress to build our website. And it's totally trivial. You don't need to run a blog with WordPress. You can run a pretty decent website with it. We decided to build a bug tracker. I mean, Linus, of course, writes bug-free software, But occasionally people make feature requests via our bug tracker. At this point, I have to say we get about 3 times as many spam tickets as actual tickets, which either means our software is of very good quality or the spammers are just really annoying. But one of the things that is fun, apparently 2 people in my community, in the subsurface community, are people that for a number of other projects are track cleaners. So they just subscribe to the track list, and whenever a new ticket comes in, take a quick look and they delete it if it's spam. It's fascinating. Whenever I see the spam tickets come, by the time I get to the website, they're gone. It's awesome. Marketing. Marketing is interesting. So the open source community is, as we saw this morning when Sir Tim gave his presentation, we're kind of odd. It's very closed, I think is the word, which is funny for the open source community. Within the community, it's very easy to find, to reach people, to get your message out. Linus posts on Google Plus and 2 million people read it. It's pretty easy to get the message out. What is interesting is that outside of our community, we are completely unknown. No one has ever heard of us. And I talked to a couple of dive computer vendors about that. And so we're talking to the dive computer vendors to get access to documentation, to loan on computers, to whatnot. And it's very funny because they all say, I've never heard of you. And then you point them to the website and you send them a binary and this is awesome, this is it's fantastic software. Why have I never heard of it? It's because we don't do marketing. We have A, no marketing budget, and B, why would I? But it's very interesting to see that there is this big wide world of scuba divers out there, and most of them apparently are normal people, so not geeks, or geeks of a different kind with more like a narcosis fetish than a electronics fetish. And so if I look at the download numbers that we get massive peaks of downloads whenever one of the normal people speaks at some dive club meeting, at some event for divers and mentions subsurface. So one of our divers in Germany is pretty active in the local communities. And I can literally see from my download charts when he's speaking at an event. Because suddenly, boom, 100 people download subsurface. But to me, this in a way, this is a failure of what we do and how we're doing it. Because at this point, we are, I would say, reasonably usable and certainly better than a lot of the commercial programs out there. Yet a lot of people buy the commercial software because they don't find us. Now, if they happen to know the word subsurface, oddly enough, when did I set up the web server, Linus? About a year ago? So I went within a few months from nowhere to be seen when you Googled for subsurface. At this point, my website is the #1 hit for the word subsurface, even though we couldn't get subsurface.org or com or net or anything. They're all used by other companies. So it's simply just on subsurface.hoondle.org. And still it's the #1 hit. So once you know what you're looking for, it's easy to find. But if you look for dive log software and things like that, it's very, very hard to find. Sometimes I try to match the picture with the topic. This guy is pretty fast. This is Mala Pier in Maui, and he was pretty big. He was like 6-7 feet long, and my camera, I have a cheap little point and shoot, and it takes a little while between taking pictures. So this picture I took, and then he saw me, and he wanted to know who I am, and he came towards me, and I was desperately trying to get this second picture. And then I do have the picture where you see his tail fin swimming away. But he literally came to about here and then turned away. So yeah, he's fast. Anyway, how fast can you move in a project like this? This comes a little bit back to what I said earlier, that there's tools for everything. We literally had a semi-working piece of software within 3 weeks. We had something that could download dives, display them. It may have had a bug or two, but it was almost useful. We're now 15, 16 months into the project, and we certainly have feature parity with programs that have been out there for 10 years. We are certainly way ahead of most of the vendor proprietary programs, besides the fact that they only work for one sort of dive computer. But usually once you use those programs, they are very, very limited in what they can do. And interesting enough, we have a couple of dive computer vendors who are now saying, oh, maybe we should use Subsurface as our program. So we'll see that. But the thing that I found most interesting about writing the dive log and working on this was this issue of visualization, because that's a fascinating topic, and that is something that most of the proprietary software does a horrifically bad job with. And oh, by the way, if you look at the question of data visualization, there are a couple of really good. I mean, anybody know Information is Beautiful? Yeah, it's a blog, and it's all about how do you visualize data, how do you make data accessible easily. And especially in the case of scuba diving, the data that we collect at the first degree, it's trivial. Okay, so what does your dive computer track? It tracks how deep you are over time. That's a two-dimensional plot. Awesome. Very, very fascinating. But once you start and correlate the different types of data that you get, so you may have an air integrated computer, so you have information about your air consumption. And then, of course, comes in the part with the math, where you try to figure out how do you normalize your air consumption, how do you come up with a standardized air consumption, a SAC rate, and how do you visualize this? How are you able to convey the information that you have to a diver? Oh, and I just said that the profile of your dive is two-dimensional data. Well, actually, it's not, because in many ways, most important part of this data is not really how deep you are. And yeah, it's fun. But for a diver who tries not to get bent, what is really useful is knowing how fast am I moving up or down. So how do you visualize the velocity, the vertical velocity in the water column? And so if you look at commercial software that tries to visualize things like this, so this is a piece of amazing software from a company named Cochrane. They do tech dive computers for the military. And most of the UI it reminds you really of DOS 6.2. So it has the nice text input fields and the block graphics. This is about the height of what they're doing. And I really love these totally intuitive timestamps. 1311, 1735, 2159. It's pretty awesome. And then the use of color in the graph, it's impressive. You can, of course, go with open source software, which is a serious improvement. I have not the slightest idea what the graph means, but it's colorful and it's a graph. And oh, by the way, these are not screenshots I did to make them look bad. These are screenshots from their respective websites that they give you to show how great they are. Okay, so I think we can do better than that. So the question is, what do you want to visualize when you dive? And we talked about this earlier, but 2/3 of you are certified divers. Or no, 2/3 of you said you were scuba divers. Okay, let's assume you are certified divers. You all have seen what PADI thinks a dive looks like. You've done on your logbook entries. So your dive works, you go in and then you're at 20 meters. And then you're there for 30 minutes, and then you go out, right? That's how you dive. Or if you have the $30 ERDP, the really fancy piece of hardware that can do multi-level dives, isn't that awesome? So to us, a dive looks more like this. Okay, that may be a little bit of showing off, but actually the resolution really sucks on this thing. See, when I tested all this earlier, I just connected the laptop, and the projector then switches into HD. This is an HD projector, so it's a 1080p projector. And you could actually read everything, you could read the numbers, and it was almost useful. This is...
One of these rooms had a sign up saying the explicit screen resolution, which the only thing that works.
No, so I was just asked to switch to 768 because of the recording. And in 768, this looks totally like crap.
Could you temporarily switch it just for...
I think I don't want to mess with the... What I will do next is this. And so I will try to actually get this to be on screen, full screen, and then most likely I will regret this, but I will try. Let's see. Okay, escape. Okay. Woohoo! It's only slightly large. But now you can read it. This is awesome. Okay. Well, let's not claim awesome just yet, but at least it's useful. So what are the things we're trying to visualize? I mean, there's obviously a lot going on in this picture. The first notion is you have this depth graph. That's fine. 54 meters was a fun dive. And then you start with a little deco stops, and clearly my buoyancy sucked on this dive. But then once you start looking a little closer, you see, oh, look, the colors change. There are different shades of green, and then it turns yellow and orange, and ooh, bad Dirk, it turns red. So basically what we do is we visualize your vertical speed as a, how well am I doing? As a diver, you're supposed to not change levels too quickly. That's one of my favorite features of this software, is you can make everything really big. You can scroll. So you see, this is diving with an instructor, and so every few minutes the instructor stops and turns around to make sure that we actually are still following him. And you can totally see this in the graph, because for a brief period of time, I don't go down further, I stop. That's because Don stopped, and again, and again. And then on the other hand, on the way back to the deco stops, you go faster, so the colors are a little more aggressive. As it gets more to red, you're going fast. And then sometimes you go too fast. And then you kind of try to rest and stay below your ceiling. Okay, so this is the first part. You see just your profile and how your change in depth is visualized. Now the next thing that is interesting, usually for a diver, is this stuff here. Breathing. And obviously I was kind of nervous in the beginning of the dive, and I continue to be nervous, and oh wait. Okay, so I clearly was breathing a little more than I usually do. And then at some point we are almost empty, and my dive computer tells me, oh, damn it, RGT alert down here. So remaining gas time, because the main computer from which this plot is connected to my twins, and it says, hey, you don't have a lot of gas left. You're like 30 meters below the surface, and you have 87 bars. That's not a good plan. But thankfully we had 2 stages with us, so then we switch over to another tank, which is still full, and you breathe that tank, and then once you hit 10 meters up here, you switch to your third tank. Ooh, this is, okay, it's better to see here. So basically we track the different tanks that you breathe. And one thing that we haven't implemented yet, I actually had with me 5 dive computers on this dive, I'm sorry. And so I had 3 different air integrated computers, one each connected to each of the tanks. What I haven't done yet is to overlay the tank pressure data. So this here right now is simply a linearization. Well, you can see it's bent because it's linearized by sec rate. So it assumes a constant sec rate, and then the more shallow you go, the less air you breathe, obviously. So that's the next thing you see. You see the visualization of your air consumption. And again, you can see, and this works better if you have a single cylinder, because here the data for these 2 cylinders is obviously not there in detail. But you can see where you breathe more, where you breathe less. And so when I go to the dive in Maui where I took the picture of the shark, you can see in my dive when that shark was swimming at me. Strangely, the breathing rate went up. Who would have thought? Then one of the things that I always love to point out when you dive in the Pacific Northwest in the winter, the temperature graph. We all know you go into the water, and then the deeper you go, the warmer it gets, right? Isn't that how it is? No. Yeah, for us it is. And it's actually 7.9 degrees at the surface. Isn't that cold? We've been there where it was much colder than that. And then once you are below the thermocline, you're between 10 and 11 degrees all year long. It never changes. Summer, winter, doesn't matter. Which is, no, it means you're a dry suit diver. Yeah. In a wetsuit, that is absolutely no fun. What else are we visualizing? So we have the events. We saw this earlier. So these are the events from the dive computer. Then on some dive computers, not a lot, unfortunately, because most dive computers don't actually store this information in a useful format. On some dive computers, you can get the information what the computer thought you should be doing when it comes to deco. So the red area that you can see, the step function, that is the Wemyss Zurich. That's the dive computer that this is from. That's the Wemyss Zurich giving me my deco stops. And it has a modified Bühlmann with extra deep stops added to it. And as Linus was cursing me, I actually was running this on a slightly conservative mode. Okay. And then on top of that, you see the visualization that we do, which is a straight Bühlmann ZH16 with gradient factors. So you have a 40-90 overlay that shows, it's pretty close to what the Wemyss does, only it does extra deep stops on top of it. And one of the fun things that you can do, 10 minutes, I can do that. One of the fun things you can do here is you can say, you can show all kinds of fun stuff. You can show, for example, your PN2 and PO2 during the dive. Oh, come on. It's lovely to do this while looking behind you. But that's not what I actually wanted to show. What I wanted to do was, you can say, oh, I'm a chicken. I don't want to live so dangerously. I want to do a 20-50. And of course, what happens is that your calculated deco suddenly goes way out. So you can play around with what different deco parameters will do to your diving. The other thing that I added here is fun little graphs that show you what's the black one is PN2, so your nitrogen load. This was trimix, so we were breathing a good bit of helium, but of course that means at 54 meters you have no narcosis with a PN2 of 3. And then you see switching over to 40% or 41% in this case. So you go up to a PO2 of 1.6, and then at 10 meters again up to 1.6 for the deco. And lots of other graphs, and then you can track your CNS and your OTUs and whatnot. And what else did I want to show? Oh, I wanted to show where we were. So we now have map integration. That's where we were. In beautiful Washington State. Let's see if I have, yeah. So there's Olympia, Seattle. And that's where we were diving.
Zoom out. They're from Australia.
Oh, they're from Australia, sorry. Okay. Oh, here, this is the problem. Sorry, guys. And ain't nothing here. Sorry. So if I try to scroll over here, then, Oh, there, right there. But anyway, so that's where we were diving. It's cold there. What else did I want to show? I think that was it on the demo. Let me think. Anything else I need to demo, Linus? Oh, the beautiful overlay that gives you way more data than you ever want to know about your dive. Okay, then let's return to the presentation. Ooh. Hey, the demo worked. That was awesome. Nice, I'm happy. So, challenges. I talked about this in the beginning. Oh, this poor pufferfish. He clearly annoyed the moray. But of course, this looks really dangerous. But there was, the moray was doing this, and by the time he decided to actually snap after the pufferfish, it was 10 feet away laughing his ass off. What?
No.
Snide remarks, commentary?
Yeah, he thinks you look like a moray.
I look like a moray eel? No, I'm way too heavy in the middle. They are much more linear. Anyway, so the problem that you have when you do a project like this is not every component is perfect, and that goes in two different ways. One, not every component that you rely upon is perfect. So as I mentioned, I'm now the #2 committer on the dive computer. But if we also try to become the #2 or 3 committer on GTK, maybe GTK would be a little better, but you can't do that. And the other thing as you do this is you notice that, oh, by the way, my own code isn't perfect. And let's make this crystal clear. Linus's code is perfect. It's my code that's buggy. And that's okay. And you need to figure out this balance of how completely anal retentive OCD crazy am I going to go to write perfect software? And how far do I want to go to write something that actually works for most people and makes most people happy? So far, I think we're doing a good job. We're going to release 3.0, well, with the internet bandwidth that we expect on Lord Howe Island next week. I think it'll be after we come back from diving. But 3.0 will be out pretty soon. But perfection cannot be your goal. And that's sometimes hard. It's especially hard for me because I look at these things like, I know I can do this better. But you just can't. You just don't have the time. He's making a snide remark. If you want to make fun of me, do it loudly, Linus. Everyone wants to laugh. Okay, and oh, this is a frogfish that's unfortunately slightly overexposed. But this is really awesome because this guy here, the frogfish, is like this big. It was a monster, and it's sitting on an anchor chain. This is the Cartagena in Maui, yes. And it's sitting on that anchor chain. It was absolutely stunning, this fish. And so some things look really pretty. So the visualization things that you want to do, the GPS maps, and you start doing them and you get like 60% of what you want. And then you think, oh, it's just a little bit of fine tuning. So you start using this GPS map and you realize that there is nothing left of Hawaii. I'm sure I can fix that. And then the more you drill into this and you try to get from it's almost there to it actually does what you want, the amount of work involved goes up exponentially. Some of these things, yeah, you can fix. You look at the code, you see an easy bug, and you just fix the open source project that you're using. But many of these, you quickly realize there is no reasonable amount of work that you can do that will get the parts that you use, the outside components that you use, to the point where they really fulfill what your vision is. So for me, when I look at it, okay, I want to implement a new UI for something, a new component, a new feature. And in my mind, this is totally easy. So you do this, and then this comes over here, and you click, and then it never works that way. And it's really, really frustrating. And the frustrating thing is that you can get to something that looks like it would be easy very quickly. And it's almost impossible to get to something that really works in a reasonable amount of time. And to me, in this project, this has been the biggest frustration, that it looks like just a little more and we can be so much better, but it keeps drifting away. And that takes me, I guess, to the biggest challenging part of this. So how many does it take? This manta ray clearly didn't have a lot of friends around. But he followed us. We were a little dive group, and he liked us. So at this point, Subsurface has a very interesting community structure. We have 2 crazy people who have written about 90% of the code. We have 1 extremely nice developer in Serbia who strangely is not a scuba diver, and who saw Linus post about Subsurface about a year ago when we did the 1.0 release, and thought, oh, I want to work on an open source project, and this sounds interesting. He's not a scuba diver. And he's, at this point, our number 3 contributor. And more than 100 commits, really enthusiastic, and most everyone on the mailing list keeps saying, dude, you really need to get certified so you can actually use this software. And after that, it falls off really, really quickly. And the biggest challenge for us has been that apparently the overlap between people who are competent in GTK, people who scuba dive, and people who have time is 0. So if anyone in this room has, shall we say, a 4-year-old's skill of GTK programming, please consider yourself drafted.
I have the same frustrating experience with GTK, exactly.
We're at the point that we're actually considering switching to Qt. I mean, I'm considering switching to Qt because we have a couple of scuba divers who are semi-experienced Qt developers and who are screaming bloody murder about the insanity of using GTK.
Even people developing and committing with GTK do not understand GTK.
Yeah, so what Ben says, even the GTK developers don't understand GTK. Yeah, I made that experience as well. But fundamentally, anybody here, you guys are all diverse, all open source people. We really, really, really would love to have a few more developers. It gets really boring if every bug report has the person assigned to it. So yes, I would appreciate people who want to help with this. And with that, I go to this very inviting little guy.